we are performing the experiment to find out the focal length of concave mirror. The apparatus required for this experiment: the concave mirror, the stand to hold it, then object pin, image pin, and a scale of 100 centimeter length. Now we know this thing. For the concave mirror, the image of the distant object that will be formed at the focal point of the mirror. So first of all, focus any distant object and take its image on the screen, means on white paper, and measure the distance between that sharp image and the mirror and take the approximate focal length of the mirror. At present we are focusing that distant light on the white paper and see the sharp image of that light is formed on the white paper. Now we have to measure the distance between this image and mirror, and that will give us the approximate focal length of the mirror. First we have to find the index correction. To find out index correction, place the pin against the mirror, say approximately at 25 centimeter. Now we measure the distance from the upright position of mirror to the tip of the pin. But actually we have to measure the distance between pole of the mirror and pin. Now place a scale or pin tangentially touching to the mirror so that we can say it is at the pole. Now the distance between pin and this scale, at present it is 25.3 centimeter. Measure it. First place the object pin at distance 2f from the mirror and observe its image in the mirror. Now move your eyes left to right and observe the pin and image. Now you observe that when you see the pin and image of it in the mirror and you move your eye, then both will not move together like this. You will observe it will be slightly detached from each other. Now moving the object pin, slightly remove the parallax, means you have to adjust the position of the pin such that the pin and image both should move together like this when you move your eye over the mirror. Now place the object pin between F and 2F. Here object pin is the red pin. See its image in the mirror. Then after, take another pin. Which one is the image pin? Here it is a white pin. And now remove the parallax between this white pin, that is the image pin, and the actual image you are observing in the mirror. Now see the image and white pin both are moving together when you move your eye. Then measure the object distance, means the distance between red pin and mirror. Then measure the distance between image pin and the mirror, means the white pin and mirror. Then repeat the experiment for 5 different object distances. It implies that place this red pin at 5 different positions, and for each position find out the image distance. Now in our experiment, we measured approximate focal length 10.5 centimeter. Then actual distance of object from the mirror that we measured 25.3. That is the distance from the pole to the object pin. And then we measured the object distance from the position of the mirror, that is 25 centimeter. And now index correction, that will come to 25.3 minus 25, so that is 0.3 centimeter. Now in our experiment, we measured approximate focal length 10.5 centimeter. Then actual distance of object from the mirror that we measured 25.3. That is the distance from the pole to the object pin. And then we measured the object distance from the position of the mirror, that is 25 centimeter. And now index correction, that will come to 25.3 minus 25, so that is 0.3 centimeter. Now for example, we will take one observation and will carry out the calculations. Say, position of the mirror, that we have to consider the reference position, so it is 0. Now the object pin is placed at 15 centimeter, and corresponding to it we get the image distance, that is 45 centimeter. So here the object distance, that is always negative, so we have to write the observed value of the object distance, that is minus 15 centimeter, and we are getting image towards the side of the object, so that also we have to take minus 45 centimeter. Now with index correction, our observations will be the object distance is minus 15.3 centimeter and image distance, that is minus 45.3 centimeter. Now F equal to UV upon U plus V. Using this formula, calculate the focal length of the mirror. So F1, that is minus 15.3 into minus 45.3 upon minus 15.3 minus 45.3. And now solve this one. You will get answer minus 11.43 centimeter. Now for another 5 observations, calculate the focal length. Now take mean of the focal length using this equation. F equal to F1 plus F2 plus F3 plus F4 plus F5 plus F6 by 6. Now to calculate the error, use this equation. So finally we will get delta F, that is F square into delta U upon U square plus delta V upon V square. So you can write delta F1, that is equal to F1 square into delta U upon U1 square plus delta V upon V1 square. Now here delta U and delta V, that we have to take 0.1 centimeter, that is the least count of the scale using which we take the measurement. So least count of the scale, that is the possible error in the measurement of image distance or object distance. F1 we already calculated, and U1 and V1 that we have to take from the observation table. Then carry out the calculation, we will get delta F1. And for remaining 5 calculations, use F2, F3, F4, F5 and F6 and the observations from table. Then from the calculations of delta F, take the maximum value of delta F and write down here. Then your final result, that is the mean value of the focal length plus or minus this maximum value of delta F, that is your final result.